Hi, I'm Jordan Schmidt, and I'm going to be showing you my math code that I wrote in Java. So I have some different types of math that this program can do. This little about program says everything. So we have solving linear systems in slope-intercept form, turning linear equations in standard form into slope-intercept form, solving linear systems in standard form, and so on. So we have 6 different programs here. So now I'm going to be showing you the code in all of them and the math behind it all. So first we'll start with the slope-intercept form. So this is really simple. If you solve any slope-intercept form equation, a system of them, of course, so it would be mx plus b equals mx plus b if you're using substitution. To find when you solve for x, eventually by using SADNEP, which is the backwards order of operations, you will get this equation shown here that gets x. And then, of course, you just plug in x back in to y equals mx plus b, which is slope-intercept form, to get y. Then there's systems of equations in standard form. So here I use something called Cramer's rule. And basically, you just put in the a, b, and c values of your standard form equation, which is ax plus by equals c, and you can get x using this one and y using this one. So it's pretty simple. And then I also have standard to slope intercept, which is how you transfer a standard form equation into a slope-intercept form equation. So, it's really simple. You have ax plus by equals c. So, if you just use and solve for y, you will eventually get what I'm about to show. So it's by equals negative ax plus c divided by b is y equals negative ax over b plus c over b. Now, so this is a slope-intercept form with standard form values. So to find the slope, which is final m down here, you would take negative a over b, as shown here. To find the b, you just do c over b. And then this b, of course, is the y-intercept. Then we have quadratic. So here we're just using the quadratic formula. Pretty simple. Just plug in the values, you get 2 x's, and then plug them back in to your equation to get the 2 y's. Vertex form is the same thing, except first we make our vertex form equation into a normal standard form quadratic equation in order to use the quadratic formula and get the a, b, and c values that we need that are in a standard form equation, as shown here. So, because this is standard form, and we need to get the a, the b, and the c to use the quadratic formula. However, in vertex form, we don't have those values. So, we have the a, but no b and c. So we solve those using these equations here. Then we have the standard quadratic form equation to make it into a vertex form equation. So basically, we solve for h using the normal formula whenever you're doing that kind of math. So that's h equals negative b over 2a, which is a little piece from the quadratic formula. And then you just plug in h back into your standard form equation for x. So it would be a times whatever that negative b over 2a was squared, because x is squared, plus b times that negative b over 2a, not squared though, because this x is not squared, plus c. So as simple as that. And then again, we have the about screen. Now I'm going to be showing you guys how the code actually works. So to run an executable jar file, you have to select your command prompt and type in java-jar and the name of your jar file. So mine is javaprogram.jar. Hit enter, and here we go. So I'm going to be showing you the programs now. So solving linear systems in slope-intercept form is the first one. Type in 1. It shows the practice problems. So as you can see, you just solve using substitution. So in this case, of the first problem, you put in 2 for the first slope, negative 4 for the first y-intercept, negative 1 for the slope of the second equation, and negative 1 for the y-intercept of the second equation. Click enter, and you get this answer. If you did this by hand, you would get the same answer. Next, you can click About to go back to the About page, so you can select a different program to run. So, in this case, we'll do the second one. So, it works the same way. Just follow the instructions. So, enter the a value of the equation, because this is standard form. So, we enter a 2, and a 1 for the b value, and a 1 for the c value. Then it gives you the slope-intercept version of the equation you told it to transfer. Next is solving linear systems in standard form. Same idea. Enter the a value of the first equation, of the second equation. Sorry, that was the b value of the first equation also. Now it's the c value of the first equation, the a value of the second equation, b value of the second equation, and c value of the second equation. Okay, so simple enough. Then there is solving quadratic systems in vertex form. Again, same idea. A value is that negative 3 in the first one. Now, the h value, remember that the h is always a negative h inside vertex form equations. So the h value is actually 2, not negative 2. And then the a value is negative 4. And then now to the second equation. And this system has no solution. So we can go back to About. And there's number 5, which is turning quadratic equations in standard form into vertex form. Okay, so here we go. The a value is 1, the b value, negative 8, and the c value, 15. So here would be the vertex form equation. Back to About once again. And now for the last program is solving quadratic systems in standard form. So, once again, just enter the 1, the negative 5, and the 7 for the first equation. Now, since this is a slope-intercept form equation, but technically it's also a standard form quadratic equation, because if you enter a 0 for the a, and then a 2 for the b, and a 1 for the c, it ends up being a vertex form equation. Hence, you can get an answer. In this case, it's infinitely many solutions. Now, so stop the program, you can type in stop, or you can go back to About, and then type stop from there. Thank you so much, and see you guys later.